Okay, so today what we're going to do is we are going to learn about functions. So this goes with 3.1 in our book, section 3.1 in our book, and this is going to be functions. And today is the 16th. So in order to know about functions, we have a lot of vocabulary that we need to know about. So the first word is relation. And a relation pairs inputs with outputs. So pretty easy and straightforward there. So when you think about this, the pairing of inputs and outputs, one of the things that probably comes to your mind is like an input-output table where we have an input and then we have an output, right? That's something that we've seen in courses prior to this class. So when a relation is given as ordered pairs, the x coordinate are inputs, and the y coordinates are outputs. Okay, and so that is a relation. We've used relations in the past in course 1, 2, and 3, probably even elementary school. You just didn't call them that. Okay, the next word is function. Okay, and a function is a relation that pairs each input with exactly one output. So this is a relation that pairs each input with exactly one output. Okay, and the key there is to understanding what that means. So each x can only have one y. It cannot have multiple y's. And then we have a couple more very quick just vocab words before we get started, like solving math and doing some math problems. So the first one is domain. And the domain of a function is the set of all possible inputs. So the domain of a function is the set of all possible inputs. Okay, so keywords here, all possible and inputs. So this also would be my x values. That represents my domain. And then my output is going to also be referred to as the range. So the range of a function is the set of all possible output values and these are the y values. Okay, so my domain is looking at my x, my input, the range is looking at my y, my output, and then we have dependent and independent variables, which I'm not going to define for you because that's something we definitely used in course 2, 3, and in science class. So there's an expectation that we know what those are. With that being said, we are going to take a look at, is it a function or not a function? That's basically going to be what we are covering today. So is it a function or is it not a function? And then the reasoning behind it. So when we take a look at this, we are going to be looking at different things. Here is going to be a list of ordered pairs. So example 1. So I have this list of ordered pairs. And then I have to determine if this is a function or not a function. So when I have a list of ordered pairs like this, one of the easiest ways to determine if it is a function or not a function is by creating another sort of diagram or organizational table to figure out how many outputs each input goes with. So sometimes it looks like this, and we call this one over here inputs, which would be my X value. And then this over here is my outputs, and this is my Y values. So when I look here, my X's, -3, -2, -1, 0, 1. Those are all my X values. I got those by just identifying the X in each ordered pair here. And then I'm going to look now at my Y values or my outputs. So 1, 1, 1, 1, 1. Okay, here we go. So there's one output here and it's 1. So now this input goes with this output, this goes with this output, right? Each one of these goes to this output. So now we look at what a function is. And the definition of a function is that it pairs the input with exactly one output. So does each input only have one output? When I look at my inputs, my X values, does each one of these only have one line going from it? I see some head nods. So the answer is yes. This is a function. So the relation is a function. Every input has exactly one output. So we know it is a function. Then part B here, we're going to look at this again. We have 1, 3, 2, 4, 3, 5, 1, 5, 4, 6. Yes, ma'am. How may I help you?
So the it can be the same. It's just as long as the input has exactly one output.
Right. So it doesn't matter what the output is. What matters is that there's only one input. Okay. So when we look here, Again, I'm going to have my inputs. And this is my X values. And then over here, I have my outputs. This is my Y values. So I'm just going down the line. 1, 2, 3, 1 I have 4, and then 3, 4, 5, 6. So all I'm doing is I'm listing the numbers that are in my X and Y spots. Okay, I never write the number twice. Just so that's like I'm not writing the number 2 times in a box. Okay, so now I go, I have 1, 3. So I have 1 and it's going to 3. I have 2, 4. I have 2, it's going to 4. I have 3, 5. I have 3, it's going to 5. I have 1, 5. So now I go back to 1 and it's going to 5. And then I have 4, 6. So when I look at this one, I can see that this input here, number 1, has 2 outputs because it has 2 lines coming from it. So because this input of 1 has 2 lines coming from it, it is not a function. So we would write the relation is not a function. And then we would say the reason why. Input 1 has 2 outputs, and then we would say what those outputs are, 3 and 5. So we're identifying the reasoning behind why it's not a function, and we're giving the mathematical evidence to back up the reason. So that is essentially what we are doing when we're looking at a table or a list of ordered pairs and we're trying to determine, is it a function or is it not a function? I'm looking at my inputs. So my X values. Is my X value repeated? If my X value is repeating, then it is not a function. Now, the reason for this is because, again, the definition of a function is that each input has exactly 1 output. We can also look at another way to tell if things are a function or not, and that is looking at the vertical line test. It's okay if the Y value is repeating. The Y value is less important. Sorry, Y value, but that's the truth. Okay, so vertical line test. So things to know, a graph represents a function when no vertical line passes through more than one point on the graph. So what we're going to do is we are going to take a look with some, we're just going to do like a janky graph here real quick. Okay, so we're going to look at my example A that we did a minute ago. And we are going to take that and we're going to just throw it on a graph real quick. Okay, this doesn't have to be a pretty graph. It's fine. So here we have it. Here is my graph. I have 1, 2, 3, 0, and 1. So this is -3, -2, -1, 0, 1, and then these all go to 1. Okay, so now I'm going to plot these points. So I have -3, 1, -2, 1, -1, 1, 0, 1, and 1, 1. So if I was to connect these points, I have a horizontal line, which would mean that I have a 0 slope. But if I look at the vertical line test, so vertical lines go up and down like my pencil. And when I move it across, it's only touching one point at a time. Therefore, it's a function. Okay, so again, a vertical line up and down. I move it across the graph. If it's only touching one point of the graph at a time, then it passes, and this is a function. Then when we look at B, okay, oops, sorry, got to move that up for you. B, I have 1, 2, 3, 4. I have 1, 2, 3, 4, 5, 6. So my first one is at 1, 3. So 1, 1, 2, 3. My next one is at 2, 4. So 2, 4. Then I have 3, 5. And then I have 1, 5. And then I have 4, 6. So now if I was to do my vertical line test, I put my pencil vertical, and as I'm going across this, when I hit here, so everyone see this, my pencil's touching 2 points at once. Therefore, it does not pass the vertical line test, and it is not a function. Because this input, this X value, has 2 outputs. Questions about that? Everyone's okay with that one? Okay. So we're going to take a look at just some other really, let's see. Here's example 3. See if we can do this one. This one says the function c equals 6t plus 8 represents the cost C for t-shirts plus shipping. So A, identify the independent and dependent variables. And then B, if the domain is 1, 2, 3, 4, 5, what is the range? Okay, so we have 2 things going on there. So I'm just going to read back over what everyone should have written on their paper. It says the function c equals 6t plus 8 represents the cost C for T t-shirts plus shipping. A, identify the independent and dependent variables. And the domain for part B is 1, 2, 3, 4, 5. What is the range? Okay, so while looking at this, the first thing we're going to do is identify the independent and dependent variables. So the independent variable would be whatever happens by itself, right? Like it's not changed based on other circumstances. So what would the independent variable be here? What's going to happen no matter what, and that part is not changing?
The number of shirts.
Okay, so the independent variable is T for our t-shirts, right? The cost of my t-shirt, or the amount, I shouldn't say the cost of my t-shirt, the number of t-shirts that I'm ordering doesn't change based on anything. Like I either order one or I don't order one, okay? Then my dependent variable is going to be what?
C.
C, the cost. So the reason that that's my dependent variable is because the cost is going to fluctuate based on the amount of t-shirts I buy. So the cost is dependent upon how many t-shirts I purchase. Everyone good with those? Okay. So now down here we have the domain and range. And again, we have a function, or, well, we're not quite sure yet if it's a function. So I should say a relation. So what we do when we have something like this is we create an input-output table. And your input-output table should have 3 sections to it. So this is what I personally like them to look like. Over here is going to be my X. You also know this as the domain now. And then over here is going to be my Y, which is also my range. And then in the middle is where I'm going to put my equation, which is what we're putting the domain into and getting the range from. So my equation here should be the 6t plus 8. My domain was given to me in this problem, so my domain is 1, 2, 3, 4, 5. And then what I'm going to do is I'm going to do a little input here and then come up with an output. So this is 6, substitute 1 plus 8. So 6 times 1 is 6 plus 8 makes 14. Now I have 6, substitute 2 plus 8. This makes 12 plus 8, which is 20. This is 6, substitute 3 plus 8. That makes 18 plus 8. That's 26. 6, substitute 4 plus 8. That makes 24 plus 8, which makes 32. And then I have 6 times 5 plus 8 would make 38. So now my range is going to be a list of these numbers. So my range is 14, 20, 26, 32, 38. And this is my range. Okay. You guys have done this before. This should feel very review-like. So possibly the only new thing really is the idea of, is it a function? Is it not a function? And how do we tell? We're using that vertical line test to determine how many points does the vertical line touch when crossing the graph. So again, it's on A, it's only touching one at a time. On B, it touches 2 here, so it's not a function. And then we are also looking at these tables, and we are double checking that my input only has one output. So my input has one line coming from it. That makes a function. If my input has 2 lines coming from it, that makes it not a function. So that is what we are going to be working on. Is it a function? Is it not a function? How do we know? What math evidence do we have to support that? So that is functions and relations in a little bit of a nutshell.